Hey everyone, we are introducing trig functions today. There are 6 of them. You guys have learned 3 of them so far in geometry. This is the other 3. So we're going to do all 6 of them today. Let's go ahead and start with our right triangle. And we'll put theta down here. So there's your theta. And we'll say this is A, B, and C. Okay. Our 6, we have sine, cosine, and tangent. You guys know already. There's also cosecant, secant, and cotangent. These are all abbreviated with 3 letters. Okay, so let's talk about, in fact, let me swap this one out. Let's talk about the placements on these. So sine, you guys know SOHCAHTOA already. Sine is going to be, we'll say sine of theta, we'll keep that there, is going to be opposite over hypotenuse. Its reciprocal function is cosecant. And what we mean by reciprocal is we're just going to flip this one upside down. Hypotenuse over opposite. Cosine is going to be adjacent over hypotenuse. Its reciprocal function is secant. That is going to be, again, this flipped over. Hypotenuse over adjacent. And we have tangent is going to be opposite over adjacent. And its reciprocal function is cotangent, which is going to be, again, this flipped. So adjacent over opposite. Okay, pause it, make sure you get these in your notes, and then we'll go back to our other triangle with our A, B, and C. Okay. So if I want to know all 6 of them, sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. So we said sine is going to be opposite over hypotenuse. Now we know our hypotenuse is always going to be our longest side. It's always going to be opposite of our right angle. All right, so like picture yourself standing in the corner of a room. As you're looking out, you're going to be looking at the hypotenuse. Same thing here. If I'm standing in this corner where theta is, as I'm looking out, I'm seeing A. Okay, so adjacent, opposites, and hypotenuse. So this is our hypotenuse, longest side. Opposite is where you are standing and looking out at the opposite wall. Adjacent is when you're standing, if again, we're going with the standing metaphor, it's going to be the other wall. The hypotenuse is never going to be adjacent. So if I'm here and I say which one is adjacent, well, both of these lines make up that angle, but there's only one that's adjacent, and that's going to be B. So in this case, we have opposite, adjacent, hypotenuse. Okay, so sine is going to be opposite over hypotenuse, which is going to be A over C. Cosine is going to be adjacent over hypotenuse, so that is going to be B over C. Tangent is going to be opposite over adjacent, A over B. And since I put my reciprocal functions next to each other, all I'm going to do is flip these upside down. So that's going to be C over A. Secant will be C over B. And tangent, or cotangent, excuse me, is going to be B over A. All right. Get your calculators out. Go ahead and pause it and get your calculators. I'm going to do a few calculations here. So let's say say we have 7 and 25. And we're actually going to solve the triangle. So let's write that down. Say solve the triangle. When it says solve the triangle, you're finding all the all legs, hypotenuse, angles, everything. So we're going to fill this whole thing in. Now here's something you may have forgotten. We're going to find this angle first. And as I'm looking at this angle, we have opposite and we have hypotenuse. So that's going to be sine or cosecant. We're going to use sine because we have sine on our calculator. So in order to find an angle, I don't remember if you guys remember this. So let's call this x over here. We're going to say the sine of x equals opposite over hypotenuse. In order to get x by itself, we're going to use something called the arc functions. And if you look on your calculator, right where sine is, right here, if I hit second, it'll be sine to the -1. That's our arc functions, ARC. So what I'm actually doing to both sides, I don't want to confuse you too much. Let's just say for now, we're going to do the arc sine of 7 divided by 25. 25 equals x. So in my calculator, let's do that. Second sine. And we got 7 divided by, you guys can't see that, 7 divided by 25. Oops, I'm in the wrong mode. There's another lesson for you. We need to be in degrees, and I was in radians. So degrees, quit. Let's try that one again. Hey, 16. We'll just round it to 16 degrees. So there's a couple different ways we can figure out this other angle and this other side. We can use Pythagorean's theorem. There's a bunch of different ways we can use trigonometry to solve it, but let's just do 90 minus 16, and that's going to get us 74 degrees up here. And our last side, I don't know, let's call this one y, and I'm going to use trigonometry. Let's use cosine this time. So let's say we have the cosine of 16 equals adjacent over hypotenuse. Okay, so when I cross multiply that, I'm going to get 25 cosine 16 equals y. I'm going to plug that in my calculator. So we have 25 cosine of 16 equals 24.3. So y is, and we'll round it down to 24.